Alright, so let's pick up from where we left off. Alright, so this is, we talked about the growth and the decay, and let's look at the first problem. So this one says, based on the data from the past 50 years, the world population billions can be approximated by this function. So they've actually given us a function. So I'm going to just go ahead and highlight it so that. So if you look at this function and compare it with the growth formula, the general formula, it basically means that the world population, this is the starting point, 2.5 is the starting point. This is nothing but 1 plus r. Whatever is in the parentheses is normally the rate is at this point, but this is not continuous, so you really cannot compare. But this is the starting point, starting population. This is 1.0185. That means from here I can actually find my rate. But what's in the parentheses is actually 1 plus r. So here it says, what is the rate of growth? Rate is nothing but 0.0185. But if you want to represent it as a percentage, it is 1.85%. So this is basically got from this. Where x equals to 0 corresponds to 1950. That means they started studying the world population from 1950. Okay. Then it says estimate the world population using this. We are using the same formula in the year 2045. That means if x equals to 0 at 1950, 2045, how many years have elapsed between? So x, it's going to be 95. Right, except because how many years have elapsed from 1950 to 2045? So almost 100 years minus 5, right? So x equals to 95. So we're just going to go ahead and use this formula for that. So g of 95 equals 2.5, 1.0185 raised to the power of 95. That's all we're doing. That's all we're doing. So you're going to put this in your calculator and you will get your answer to be 14.264. And we know we're talking in terms of billions, so it is billions. It won't give you billions, but that's what, because we're starting with 2.5 billion. So our population after 95 years is going to be 14.264 billion. Okay, let's look at the last part of the question. In what year? So basically I'm going to be finding t, or in this case x. In this case x. Will the population be double of what it is now? So when we are talking about double, that means my final amount is 5 because I'm starting with 2.5 and then 1.0185, and this is what I'm trying to find. This is the one that I'm trying to find. This is my unknown. So divide, so get this by itself. So divide both sides. So I'll have 2.5, sorry, 5 divided by 2.5, because you want to get this. So 5 divided by 2.5 is 2, because double, and this is 1.0185 raised to the power of x. How do you get x by itself? You basically, x is an exponent, and you basically take ln on both sides. So ln of 2 equals x ln of 1 point, because the x comes to the front the minute you take 0.185. So basically x equals ln of 2 over ln of 1.0185. So this is something you can put in your calculator, right? Ln of 2 over this one, you should get x equals 37.8 or 38 years. So you're looking at 1950 plus 38. It's going to be 87? 87? 88? 8 plus 0, 5 plus, yeah, 1988. That's when you are basically going to have a population where it is doubled. Alright, this is your final answer. Are we okay? Alright, moving on to the next page. Okay, so all these problems are pretty similar. We'll do a couple of these, and so let's look at this. Okay, so this has a lot of reading to do, so let's go ahead and read. Also, I'm going to make it a little bigger. I still think it's a little small, right? So let's look at this. Okay. So it says the normal healing of wounds can be modeled by the exponential. So healing of the wounds is also modeled by an exponential function, where A0 represents the original area of the wound and just A represents the final area after n days. So this is my formula. So this is my formula, AN, which is the final area. So here we're talking about area. Area of the wound is basically A0, E raised to the power of point. What do you notice here? K is negative. K is less than 0. That means it is coming down, which is what you want. You want the area of the wound to come down. So you notice that K is negative because negative 0.35. Describes the area of the wound on the nth day following an injury when no infection is present to retard the healing. Suppose that a wound initially had an area of 100 square millimeters. That means you're talking about A0 to be 100 square millimeters. So you're starting off with that. Let's see what else. If the healing is taking place now, how large would the area be after 3 days? So here I'm talking about n equals to 3. N equals to 3. So let's go ahead and do A. So AN is what I'm trying to find. A0 is 100. So I'm just using this formula times E raised to the power of negative 0.35 multiplied by 3. Because it is after 3 days, right? I'm trying to find 3. Basically, I can even write the 3 here. Because remember, this is the x. So go ahead and put this in your calculator. Put 100 multiplied by e to the power of 0.35 times 3. You should get approximately 34.994 millimeters square. Or 35 millimeters. So basically in 3 days it has come down to what? You start with 100, comes down to 35. So almost 1/3. Almost 1/3, right? Really close to 1/3. And then it says after, how long will it take? After 10 days. So you're just doing the same thing with 10 days. Okay, you guys can work this out and see what you get. You should get, all you're doing is instead of n equals to this one, here you're saying n equals to 10. That's what you're doing here in your formula, and see what you get. You should, so this, it should almost vanish. It should almost vanish after 10 days. So if you put this in your calculator, you should get this. Alright? Okay, so you should be able to do that. So let's go ahead and look at one more such problem. So this is an interesting social problem, if I can call it, spreading of rumors. Here it says a model for the number of people n in a community college who have heard a certain rumor is, so they have even modeled a rumor. And what do we notice here? It's the R is still negative. It's negative 0.15. Because, as the days go by, initially the rumor spreads fast, but as the days goes by, it becomes smaller and smaller. Where P is the total population of the community and D is the number of days that have elapsed since the rumor began. In a community of 100 students, how many students will have heard the rumor after 3 days? So basically D equals to 3. So all I'm going to be doing is substituting D equals to 3. So let's go ahead and do that. So N equals to, I'm starting off with 100 students. 1 minus e to the power of negative 0.15 multiplied by 3. You're just going to put this in your calculator and you're going to get 36 students. So if you follow this particular model, you'll see that you have 36 students that will come up. You're just putting that in your calculator. And this is the last one. Looks like I already did some work on that. So I'll just talk through it because it looks like I've already done the work. I'm not sure. Maybe I used this for doing the work. Okay. So bacterial growth. It says a culture of bacteria obeys a law of uninhibited growth. So this is the one where you use the formula for uninhibited growth. Okay. This is same as compounded continuously. if 300 bacteria are present initially and there are 500 after 1 hour. So this is where you, because it is uninhibited growth, you are going to be using this formula, which was there in the first page of the growth and decay. So it says if 300 bacteria are present initially, so this is what you start with, A0, and there are 500 after 1 hour, so this is your AN that you like. After 1 hour, so time is N, right? How many will be present in the same culture after 4 hours? Okay, so it doesn't talk about the, do you notice something? That it doesn't talk about the K or the R, weight. But I have enough information, I think, to calculate for that K. So let's go ahead and do. So 500 is the final. I start off with 300 times E. K is what I'm trying to find. I don't know K after 1 hour because it stays here. Can I solve for this K? Yes, I can, because this is an exponential equation. So I divide both sides by 300, so I get 5 over 3 E to the power of K. And then I take ln on both sides. ln of 5 over 3 equals ln of ek, that I'm just left with k. So I actually find my k to be ln of 5 over 3. Alright, then let's see what's the question. How many will be present after 4 hours? So now instead of t being 1, t is going to be 4, and I actually have my ln. So a is what I'm calculating. Same 300 e ln of, remember k equals, I'm substituting for k equals ln of 5 over 3. And that's what I'm substituting. So I have everything on my right hand side. I'm just putting this in my calculator and solving for it. And the last one is how long will it take for it to, so here how long will it take for it to reach 10,000? So 10,000 is my final figure. I don't know t because it says how long. So 10,300, k is still the same. What's blank? What's unknown is the t. So get the t by itself using your exponential function. Your equation should come to ln of 100 over 3 equals ln of 5 over 3 over t. And so t is going to be ln of 100 over 3 over ln of 5 over 3. Put this in your calculator and you should get your answer. Alright, we'll stop here. I hope I've given you enough information on this particular lesson.